Hi, I'm Jonathan Blaustein, and this is Chloe, Abhishek, and Alexandra, and we're group 4, and we did our project on YouTube and how to predict the views of a video. So in this project, we hypothesized that it's possible to predict the number of views a YouTube video is likely to receive based on predefined attributes, including the name of the video, its associated tags, the published time, and its description.
So as YouTube transitions from hobby to career to creative professionals, creators increasingly rely on consistent revenue generated on the platform. As such, we thought it was significant value in understanding the factors that contribute to making a video become trending on YouTube. The goal of our project is to create a model that predicts the number of views a video will accumulate before it is ever released by leveraging several regression algorithms on a feature set engineered from the predefined attributes of a video, including title, tags, publish time, and description. We thought this problem was of importance because in a highly competitive video sharing platform like YouTube, views equal profits. As such, giving creators the ability to tune their videos for the highest chance of success before uploads becomes very valuable. And the implications of such a tool include an increased creator confidence on the platform by making YouTube a more stable and viable career. And also, we should note that in conducting research on similar work done in the past, we encountered a project on towardsdatascience.com that utilized machine learning techniques on a plethora of video attributes to predict the number of views a given video might receive. And they concluded that previous view count and channel views were the biggest predictors in future view count. However, a difference in our project is that we will specifically leverage a data set of previously trending videos, as we believe the trending on YouTube's algorithm is the fastest path to channel growth. Next, for our hypotheses, we hypothesize that attributes inherent to a YouTube video prior upload, including title, tags, publish time, and description, can be used to estimate the total number of views this video will accumulate. Another thing is that a YouTube video containing tags that are trending across the internet will have a distinguishable view count when compared to a video that uses more generic tags. Also, video titles containing trending Google search terms and words will be selected more frequently, therefore will have more views. And finally, since our hypothesis relies heavily on natural language processing, we predict that, or we believe that the k-nearest neighbors regressor will perform better than linear regression because there's no linear relationship, a correlation between words and their effect on views. But clusters of similar words will have kind of a similar effect on view count.
So in our methods, basically we got all of our data from Kaggle. They have a site there and a lot of information on different YouTube videos from across the globe. So we decided to focus in on the US videos, specifically those that were trending at some point in the time that they were posted. We also got information on the top YouTube hashtags as well as top Google searches, both from besthashtags.com and as well as Google Trends. Our feature variables included the variables that were known before the upload, so we didn't have any information on likes, dislikes, comments, anything that we wouldn't have known prior to an upload. And obviously our target variable in this case is the view count. In our data analysis, we use natural language processing, tfit vectorizer, n-grams, bag of words, obviously stop words to get rid of the English words that we didn't need in the dictionary. And we did some feature engineering from these external sources to create counts for each record in the data frame of how many times that a top keyword showed up within that title, description, or tag. The results of our project, obviously we used the standardized feature variables and we used RFE for our feature selection. Our top 3 models that we used using an estimator's dictionary were linear SVR, Ridge, and KNN. And after doing model optimization using hyperparameter tuning grid search CV, we determined that KNN was our top model with an attribute of n neighbors being equal to 10. So we decided to perform our final tests on these 3 models as well. And the results for the KNN model are here, with the prediction accuracy in the training set being 22.35 and on the test set 2.91.
We wanted to look at how how we could better understand our data. And one of the attributes of our data that we thought would be most relevant when looking at view count was category. So our first visualization is the average number of views grouped by category for our data set. So this shows that music clearly as a category can generate the most number of views, and comedy and entertainment take up the second place. But generally, all the other categories seem about even, with a lower outlier being the nonprofits and activism category. We also wanted to look at how our categories grew in popularity over time, grew and fell. So this is a line graph that shows each line represents a different category, and it shows how the views of that category rise and fall over the published date. So our data set goes from late 2017 to early 2018. So over the course of 2017, this is the trend of each category. Finally, we also, as we mentioned in an earlier slide, took trending tags from an external source and mapped it against our own tags attribute to see how often generally trending tags showed up in our data set. So the tag video is the most popular tag across the internet, and it shows up the most in our data set. And that falls off over the other tags.
So in order to predict target view count given, in order to predict the target view count of a given video based on its feature set, we experimented with multiple regression models, including like linear regression, lasso regression, ridge, k-nearest neighbors, SVM, and SVM. After fitting each model to our test set, we compared their R-squared scores to evaluate performance. We should use k-nearest neighbors because it yielded the best results with an R-squared value of 0.387 compared to other regressions which contained R-squared values all less than 0.09. Our regression model didn't meet our expectations. We hope to have a higher R-squared value. Yeah. So for future work, we should reattempt our experiment with a broader data set, which represents more of like YouTube's overall videos. Our data set mainly contained trending videos, but not all the videos on YouTube are trending. We could also suggest ways to improve view count based on the user's input information. For example, after like the user inputs their like upload date, tags, title, and all of that information, we could possibly suggest another tag that they could include, which will increase their view count by maybe like 1,000. And then we could also use channel title as a feature to recognize past trends by an individual channel.
Thank you all
Okay,
for
thank
watching.
you.
We hope you enjoyed our presentation. Have a good night. Enjoy your quarantine.